Boy, welcome. I had been thinking that I had been streaming this entire time. And now, because of you, Tiffany and Ray, I was just noticing that you guys were talking as if you thought I was having difficulties. But I just assumed that I was streaming okay. And the little indicator in YouTube acted like it was streaming, but when you guys said that you couldn't hear me, I went to the little indicator and I fiddled with it some, and the stream actually started up. So, man, that's such a shame because I've just, well, I'll tell you what we'll do. We'll kind of restart as if from here. Tiffany, good to have you aboard. Thanks a lot to you and Ray for your patience. And I've been watching your conversation here and talking to you as if we were live. My name is Doug. We're coming to you from the outskirts of Louisville, Kentucky. And for me, I'm re-welcoming you. But for you guys, you've apparently just started watching. So sorry about that. You're looking at a live view of our sky through our ZWO ASI2600MC monochrome camera. And that monochrome camera has been malfunctioning over the last couple of broadcasts. So last night we came and did kind of a maintenance night. If you've looked at the channel, you might have been able to see that we had several little 1 minute, what do you call those? 1 minute, not stories. Forget what you call those. When you do 1 minute on YouTube, what are they called? What are those called? Anyway, we did several of those little 1 minute stories, and I hope you can find those on YouTube during the maintenance night last night. So we got this 178 working, and I'm so glad we can now maintain a better connection with the sky. Another thing that had been malfunctioning lately was our ScopeCam. And a short, thank you, Tiffany, a short. Another thing that had been malfunctioning is our ScopeCam. And we're thinking that the ScopeCam had been malfunctioning perhaps because maybe the SV Pro webcam type camera just was not reliable enough in terms of its voltage, I don't know. So what we did is we've replaced that with a, basically it's a security camera, TP-Link TAPO, is that how you say it? TAPO? TP-Link TAPO security camera. And it is a whole different beast, and I'm happy to tell you that that ScopeCam is looking a lot better tonight. I think you can tell. It almost looks like broad daylight, doesn't it? It's so exciting. That ScopeCam is mounted on the observatory corner that's closest to the south. So in other words, we're looking up, if we could look past the scope, we'd be looking at the North Star. And so you can tell if the scope is looking off to the left, then you know we're seeing to the west. So I don't know. Are you hearing that? Yeah, evidently Tiffany's hearing. And Vic, good to have you here, Vic. Good to have you aboard with us. Ray, I wasn't using my webcam. I was letting you look at the sky. I hope you're able to see, Ray. Vic, good to have you aboard. Where are you viewing from? Nice to have you on board. So you've seen the ScopeCam, and now we're going to look at the place where we're viewing in Stellarium, which is the planetarium software we use. Here's due west, down here at the bottom. Here's the North Star, so you can see the Little Dipper, and here's Draco. Now, if you could draw a line between the North Star and the cup of the Little Dipper, go out farther through this little dim star, these little dim stars of Draco, you'd get to Hercules. Doesn't he look like a guy that's swinging around a club or something? Maybe, I don't know. Are these his two legs? This must be one leg. Is that right? Or are these his arms and he's kind of on his side? No, he's holding something here. This is this little slingshot he's got, right? So are these his two legs? I don't know. Anyway, we're looking just beside what you might call the keystone of Hercules. And you can see our target here, our field of view, we barely are spotting in our field of view M13, just almost barely right off frame. And that lets us see several targets in here, among which are IC 4616. Where is it? IC 4616. I don't see it in that view. Do you think they didn't list it in Stellarium? Let's do just a plain old search here. Control F, I think I have it set. IC 4616. Oh, there it is. Oh, I see it has two names. It's also known as NGC 6197. Okay, so you can see right in the middle of our field of view is NGC 6197, also known as IC 4616. And now let's pan over to our live. And this is the live view through the RASA's ZWO ASI2600MC Pro. And you see it there on the screen on the business end of the RASA 11. It's out there on the very end of that black dew shield. And here's the live view through that camera. Now we can tune this up a little bit. We can move this over the black line. Boy, look at those clouds. Let's do a reset here of our display histogram. There we go. And let's do a reset here and a color match. And then back off a bit. We've got some clouds working against us. And then let's look at our deep sky image annotation. Now there you see NGC 6196 or IC 4615. Here's NGC 6197 or 4616. And in the Phil Harrington list, 4616 is what he'd like for us to see as our next cosmic challenge. And it is indeed a cosmic challenge on a night when we have 64% moonlight. It looks like a splotch, basically. Just a patch in the sky, doesn't it? Ray is in Arizona. Tiffany's in San Jose. Vic, you're in North Central Texas. Tiffany, remind me the name of your Shih Tzu. I forget his name. Okay, so it's this splotch right here that is the subject of our observation. So we're going to call up observation panel here. And right here is what we're observing. So I'll scoot this off to the side a little bit. And what does Harrington say about IC 4616? Okay, he says it's a dimmer galactic smudge. Yeah, I would agree with that. The true identity is IC 4616, although some references identify it incorrectly as NGC 6197. The confusion over it is true. The confusion over its true identity dates back to German-born astronomer Albert Marth, who lived between 1828 and 1897. Marth came to England in 1853 and eventually became a British astronomer William Lassell's assistant at Lassell Observatory in Malta. Malta is an island out there in the Mediterranean, I believe. There, Marth went on to discover more than 600 new deep sky objects through the observatory's 48-inch reflector between 1863 and 1865. We were over here fighting the Civil War, so we weren't paying any attention. He bumped into this galactic pair on July 9th, 1864, but incorrectly recorded their positions. The errant galaxy, subsequently re-identified as IC4616 by French astronomer Camille Guillermet-Bigudin, after a search found nothing at Mars' original location. Bummer. Subsequent historical studies now conclude they are one and the same. So, this was misidentified when discovered first by, what was his name? Marth, is that right? Yeah, Marth. Then rediscovered by Bigourdin. It just looks like a smudge. But I suppose that's why he has us viewing it, because it is a book, after all, about cosmic challenges. And this is supposed to be challenges with a scope that's between 10 and like, 15 inches? Is that what the table of contents says? 10 and 14 inches. So it is supposed to be, after all, a bit of a challenge. And it's supposed to be magnitude 15.4. So it's coming up rather well after 11 minutes in a RASA 11. Joy, that's right, joy. I don't want to forget that. I need to make a note of that. I'm going to go down here in my, I think I'm going to go down here in Evernote. And I'm going to say a new note. And I'm going to say Tiffany's Shih Tzu is named Joy. Shih Tzu. Sounds like a Chinese word. Okay. That's just a quick little note I wanted to make. All right, now let's make sure we're not going to miss any other. Oh, there you see the edge of M13. Just the edge. It's a beautiful galaxy, isn't it? Or not galaxy, cluster. Let's go to Deep Sky Image Annotation, see if there's anything else here. Nothing else in his list, but there are some other galaxies. 6196 is not on his list, but it actually looks brighter. I think 6196 is brighter than his 6197 or IC4616. So there you go. Let's do a quick snapshot of this, but before we do, let's kick up the blacks a little. Like that. Let's get a look at our ScopeCam and see what those clouds are looking like. Still wispy, just annoying. Annoying clouds. Papa Tech, good to have you on from Florida. All right. Let's head toward the next object. And it's going to be Palomar 11. Palomar 11. What is Palomar 11? Is that double stars? Palomar 11. Oh, I forgot to take off Deep Sky Image Annotation. Oh, we'll get it in a minute. Palomar 11. So let's slew to it. Boy, it's great to have a ScopeCam back, isn't it? Man. And then the SkyCam view of that kind of makes you a little bit dizzy, doesn't it? Let's see if we can hear that mic. I'm going to mute the music. I'm going to mute the music here. By that time, the slew will be over. Let's mute the music. Pause. Yeah, we missed the slew. We'll catch it next time. And you know what? Our show chart has not been working correctly. I think with an upgrade that Stellarium did, I think we upgraded it right out of connection from Deep Sky Planner. So we have to search for these in Stellarium manually. Whew. First world problems, right? Anyway, Control F, Palomar 11. Oops, it doesn't have Palomars. PAL 11? P11? Oh, it's a bummer. It doesn't have, Stellarium doesn't have Palomars. Bummer. Well, I think if I try to use show chart, it's not working. Oh, look, there's another label. GGC 148. Let's try that. GGC 148. Huh. Let's go to Simbad? Palomar 11. So what we're doing is we're using Stellarium's connection with Simbad, which is a global database of objects in the deep sky. And down here at the bottom it says querying. Notice it says all IDs. Not finding much yet. Let's go back over to the live view. And now it'll plate solve. We're not getting anything back from the Simbad query. Wow, Papa Tech is waiting for a Falcon 9 launch out of Cape Canaveral in about 50 minutes. Papa Tech watches them from the yard. Don, good to have you aboard. Can't spot Osiris Rex. Never gets old watching rocket launches. Papa Tech watched the crew come back a few weeks ago as it streaked across the sky in front of his house. Cool. Yeah, we're just not getting anything from... Anyway, this is object number 142 in the Harrington list. Palomar 11. It's a globular cluster. Aquila. It's in the constellation Aquila. You know, I haven't been keeping up these texts, these here. This is Palomar 11 that we're trying to find. Sinbad look up found. It says found. Could it be GCI 114? It certainly is. Well done, Sinbad. So now we have our location as provided by Sinbad. And up here in Stellarium, in the upper left, it just calls it custom object. And it says we're in the constellation Aquila. But see, it does not have it in the Stellarium database. So I wonder, are we able to add this somehow? Maybe once we've looked it up, it will remember it? Anyway, our field of view is now in the south-southwest. Here's that nasty moon at 64%. And we're just above it, trying to find a globular cluster. And it's going to be right in the middle of our frame, supposedly. So let's head on over to our live shot. Let's turn off this leftover, and let's do a reset in the display histogram and a reset here in the large histogram, a color matching, back off of our mid-sum, and then make our sky a little bit darker. Pump up our mids now, and then let's zoom in. I suppose that must be our globular cluster, but they don't have the Palomar 11. They don't have the Palomar 11 object list, so thus it's a challenge. Here, let's read about it. When it was released half a century ago, the Palomar Observatory Sky Survey showed the universe at a level of detail never before achieved. This major photographic survey covers the sky from the north celestial pole to -30 Dec and recorded stars down to an average magnitude of 22. Astronomers at the time immediately turned to the survey's 900-plus photographic plates to examine known objects in exquisite detail, as well as to discover other sites that earlier studies had missed. We've already met a number of planetary nebulae discovered on the plates by George Abel, but now we turn to a previously unknown globular cluster that was also discovered on those plates. During a survey of the survey, Abel, along with Halton Arp, Walter Bad, Edwin Hubble, and Fritz Zwicky, A.G. Wilson, and others cataloged 15 unknown Milky Way globulars. Each represents a suitably daunting test for today's most die-hard deep sky observers. That's us. Table 6.4 lists the vital statistics of these clusters, and we're looking at one of them. Palomar 11 is challenge 142. It's magnitude 9.8 overall, but it's scattered among all of its objects. It takes up 10 arc minutes of the sky, and you can see how it might have escaped earlier detection. Now I'm looking at the star chart they gave us, and I want to zoom in on this star chart so you can see what we're using here. So using the star chart, this must be the SAO 143755, and those two stars must be right there. Yes, those two right there, and they form a kind of an arc. So these are part of the cluster. Well, how about that? So this is Palomar 11. And we're going to say, looks visually like maybe 50 rather loose stars relatively nearby, 42,000 light years away. 42,000 light years away. It's a victim of circumstance. In between us and it are rich clouds of interstellar dust that muffle the cluster's true luster. Were it not for these nearly opaque clouds, Palomar 11 would undoubtedly be far more spectacular. But as it is, Palomar 11 is only a vague glow, a mere whisper of its true self. Harrington explains that it's located on the other side of several what would that be, like opaque clouds of dust that prevent it from shining. So how about that? Kind of some metaphor there, I'm sure. Stu, you're back. The Palomar globulars was discovered late due to being very faint, heavily obscured, remote, or having few member stars. These were discovered only with the enormous 48-inch Schmidt camera at Palomar. Thanks, Stu. Tiffany says, Stu, thank you as always. You're amazing. I could have just looked here. You said it is 42,400 light years away. Stu brings up that the Mars helicopter flew for the 59th time the other day, setting a new altitude record while doing so. Comet Nishimura has been an early morning object, Don, so we haven't gotten up at 4 a.m. to go see it, but I've seen some good pictures of it. All right, we're going to snap a picture of this, speaking of pictures, and on to the next object. Which is NGC 6803. NGC 6803. And we'll give you the ScopeCam. Stu, take a look at this ScopeCam, Stu. How about that? Looks like broad daylight out there, doesn't it? That's a security camera. It's made by TP-Link. It's called the TAPO, T-A-P-O, TAPO. Doug doesn't do mornings. Not when we're burning the candlelight on this end, Stu. Well, anyway, and look, we've got our SkyCam back as well, Stu. I don't know if you were on when we talked about this a while ago, but we just basically unplugged all the cables, and I chose a different socket in the Pegasus Astro USB hub. Made sure that we turned that hub on. I know, the clouds don't look good at all. Take a look at them. They look wispy and ugly, don't they? Yikes. But we'll do the best we can. Now back over here in Stellarium, let's do our Control S search. I'm sorry, Control F for find. And let's look for NGC 6803. So this is looking southwest, kind of along that Milky Way band. Look at that. It's in Aquila, or Aquila again. Just for orientation, there's a bright star in Aquila called Altair. I'll tear this place up. Let's go over to our ScopeCam for a second. And let's see if we can make out Aquila the Eagle. So the moon is down here, this little search beacon. So there's the moon. Can anybody make out Altair? Which one would be Altair? Maybe this or this? The clouds don't help a bit. There are two close stars there. There's the moon. What's that, I wonder? The flying saucer? Not seeing it. This is a nice little triangle. Wonder if it's up this high. No? Anybody seeing it? Oh, I'm glad you got a picture of the comet, Don. Your son got married, Don. Well done. Can anybody help me make this out? Anybody help me see which is which here? Can we take these constellation lines off for a second? So, the moon's here. The moon's here. There's 3 stars in a row with a bright star in the middle. 3 stars in a row with a bright star in the middle. That's it. That's Altair. So here's Altair. Now let's put the lines back. Three stars in a row with a bright star in the middle. So this must be the left arm of Aquila, and this is the right arm, and that's the star Ocab. Almisan the third is out here. And this, again, this is a live view up here that we're looking at. This is the tail of the eagle here. See the tail of the eagle? So our RASA is aimed right about here, in between OCAB and Altair. Here's Altair and here's OCAB. I kind of like this. I mean, if we were out there under the sky, we were aiming any kind of camera up at the sky, you guys wouldn't be able to see this live streamed because it would just be super dark for any kind of normal camera. You'd have to take a time exposure and then send you one picture of that time exposure. But with this ASI, this ZWO ASI178, we're doing 3-second exposures. We can show you this live. And I can try to learn Aquila as well. So right here is where we're looking. So now let's go to the live view and let's do our display histogram reset and the large histogram reset and the color mapping, color balancing. Move the mids out a little bit. This is a busy part of the sky with all the Milky Way there. Now we're supposed to be looking for NGC 6803, which is a planetary nebula. I have a feeling we ought to do one more solve only plate solve. Could that be him right there? Let's go over here and zoom in now. Just looks like a star, doesn't it? NGC 6803. Up here it calls it a star. So this must be the thing that it's classifying as a double star. But it's really a planetary nebula. Now let's put our deep sky image annotation on again. Oh, which one is it? Oh, look, it's drawn a circle around it. So it was not that double star. So score 1 for deep sky image annotation. Magnitude 11.4. Boy, it's shining pretty bright there, isn't it, for 11.4? Now let's get a sense of where we are here. So it's right here. It's the right-hand view. Let's take deep sky image annotation off right here. There's a bit of a green cast to it. But just for perspective, that's 200% optical zoom. Digital zoom. 100% of the optics of our ASI2600MC Pro would be right here. This is a tiny object, and it's object number 57. Oh my goodness, he doesn't say much at all about it. 6803. It's found a little less than 4 degrees west of Tarzed, the American astronomer Edward Pickering was first to lay eyes on this tiny target, September 17, 1882, using a 15-inch refractor at Harvard College Observatory. Pickering is most famous for his work determining characteristics of stars by studying their spectra. Truth be told, much of Pickering's acclaim was due largely to the computational work performed by more than a dozen female astronomers who assisted him. Known in certain circles as Pickering's harem, his team of assistants included several people, Cannon and Henrietta Swan Leavitt, and several others. Each went on to make many important contributions to science in her own right. You'll find NGC 6803 at the end of a meandering line of 8 eighth magnitude stars. I guess this would be this? No, this maybe. Just 10 degrees south of the 9th magnitude star, HD 183850. The problem is telling NGC 6803 apart from the rich surrounding star field, since this tiny disk measures a scant 6 arc seconds. This planetary nebula is only 6 arc seconds wide. Right there. So if you want a visual benchmark of what 6 arc seconds look like, we're zoomed in at 100% optical. And even at 100% optical with our 2600MC Pro, this is just 6 arc seconds. Even viewing at 200 times through my 4-inch refractor on a night of exceptionally steady seeing, it is still tough to tell which is the planetary and which are just faint surrounding stars without a little help. So he gets a spectroscopic view going, and uses filters to blink out the planetary nebula, which focuses most of its energy in the narrow portion of the visible spectrum. And he says that helps you find planetaries, planetary nebulae. Boy, I don't know if we would have picked it out, would we, gang? It would be hard. Tiny. Stu says, can't find anything about it. I think this will be tough with just visual observing. There's no central star visible. And look how close it looks to that star. All right, let's do our observation on this. I kind of like these because each one is like a treasure hunt. It's a different kind of astronomy, isn't it? You know, normally we're looking at big objects that are, you know, but this cosmic challenge thing, this is more like, you know, testing your metal, M-E-T-T-L-E metal. This planetary is indiscernible from the stars around it. No wonder they really only detected it via spectroscopic analyses. And again, it was all those right, is that better? So sorry. Testing, 1, 2, 3. Is that better? Hello. Is that better? So sorry. Yeah, what I did is just switch to the mic that's in the webcam here. And it looks like that's, by the looks of the VU meter. So I'll just show you the mic that I normally use. And I have to do some testing. Normally I have on this lavalier with this little pocket transmitter, and it usually does okay with this little receiver down here, but not so tonight. Who knows what? You know what I could do is pull out a different receiver, unless this mic is okay, isn't it? It looks like it's working all right. Let's just stick with this for now. Yes, you can unmute. All right, that's a little bit, maybe a little bit too hot. No, maybe that's testing, 1, 2, 3. Testing, 1, 2, 3. All right, tell me if that's better. I have the music turned off. We'll just leave the music off for now. Let's capture an image of the, we're not going to capture an image because it just looks like a star field. There's nothing worth capturing there that we're going to see in a picture, is it? SpaceX doesn't live stream their launches on YouTube anymore. Well, that's sad. I thought I just saw them the other night. That must have been a recent change. Now we've got a couple of dark nebulae. Barnard 142 and 43. Barnard 142 and 43. Boy, that was pretty close. That didn't slew for very long, did it? All right, while that's calculating, let's go back over here and Control F, Barnard 142. Must be otherwise known as this. Oh, it was almost in the same field. Yeah. Look at that. Is that not cool or what? What a cool river of dark matter. $16 minutes till that launch. The E, or Barnard's E Nebula, officially designated as Barnard 142 and 143, is a pair of dark nebula in the Aquila constellation. I hope we can see it through these clouds. Let's have a look at the, oh my goodness, look at the mess of soup. Wow. I hope we'll be able to see it. Look at all the clouds. It's so sad. Okay, let's do our display histogram reset and reset this and reset the color. No, we might be able to see it through the clouds, huh? So it's interesting, isn't it, that in this case, we're not looking for an object that we can see. We're trying to look at what we can't see, because these are dark nebulae. A well-defined dark area on a background of Milky Way consisting of countless stars of all magnitudes. Its size is about that of the full moon. The distance from Earth is about 2,000 light years. 142 and 143. This is object 31. 31. This is actually a binocular challenge. The Milky Way in and around the constellations of Aquila and Scutum is littered with huge wafting clouds of cosmic dust. These vast expanses of dark nebulosity are clearly visible on a long exposure photograph on the area as they strike a pose against a bright starlit backdrop. Trying to spot them visually, however, without the benefit of being able to amass photons from the distant starry milieu, let's try to use the word milieu from now on, can prove very difficult. After all, when it comes to observing dark nebulae, it's what you don't see that counts. One of the more visually interesting dark nebulae within Aquila carries the dual designation of Barnard 142 and Barnard 143 for its multiple entries in Edward Barnard's catalog of 349 dark objects in the sky. Figure 310 shows the view through a pair of 10 by 50 binoculars. Barnard 143, the northernmost of the two, resembles a pickle fork, with its prongs opening toward the west. Barnard 142 lies just to the south and is shaped like an irregular starless rectangle. Both stand out nicely through binoculars provided there's no moonlight. Oops. Or light pollution. Oops. To spoil the view. The human mind always likes to create something that is tangible out of the intangible. Though Barnard 142 and 143 are included as two separate items in Barnard's listing, recent reckonings often lump both together for their combined visual interest. Today's Barnard 142 and 143 are better known as Barnard's E. That's because from under dark skies, they collectively form a very distinctive capital E against a bright background. Barnard's E, also sometimes called the Triple Cave Nebula, is easy to locate in the sky just 3 degrees northwest of brilliant Altair. A few summers ago, while observing from the Stellarium Telescope Makers Convention, the E struck me in an especially vivid way when he pointed his 10 by 50 binoculars its way. It's not very well perceived through a narrow field of view. We're going to be able to do this, I'm sure, guys. Okay, so first, see if you can make it out in this photograph. Now get a load of the stars and memorize that formation. You've got what looks like it could be a double star, maybe it's just a visual double, and then a tiny double, and then a brighter star. Okay, so looking at our field of view here, let's back up a little more. Nope, that's the whole field of view. A visual double, maybe that's off of our, yeah, there's that visual double. Maybe, or maybe this is the visual double. Boy, there's so many other stars. Look at these two stars. If we could see these two and these two, that would really help. Oops, sorry. If we could see we're on Stellarium here. if we can see these two, and notice there are 3 dimmer main stars between them. If we see those 2 and these 3. So is this, that's the rectangle of 142. And then this is the pickle hook of 143. So let's look for these brighter stars. It's 5 stars in a row with the 2 on the end being the brightest. I believe this might be it. Here are the 5 stars. 1, 2, 3, 4, 5, I think. Maybe not. There are so many stars. So does anybody see the E anyway? Can anybody make it out? Let's do this. Let's add some more light to the picture. Anybody seeing it? Anybody seeing the E? Because I'm not seeing it yet. Wait, is this the pickle fork? Is that the pickle fork? And would this be the rectangle? Or am I just imagining that? Face downish, Don says. Look. Is this a pickle fork? And that's the rectangle. Yeah, there's the pickle fork. So here's the pickle fork. And there's the bottom of the, that's the, so this is 142 and this is 143. Right. All right, let's see if we got it. Nope. Because SharpCap is the imaging program we're using. SharpCap doesn't have Barnard's list in deep sky image annotation. It is, I hate Clavin limb, it is a dark nebulosity. Don agrees that this is 142 and this is 143. All right, let's do our observation here. After some degree of searching, we could make out the rough rectangle that is Barnard 142 with around 9 minutes of integration. 9 minutes of integration just means an accumulation of 9 minutes of frames. Well, how about that? It did away with 143 when we observed 142. I must have had those paired somehow. That's sad. Let me just get rid of and then put them in order of this column. Go down and find 143. No, sorry. It's object number 31. Go down and find object number 31, Barnard 143, and say, we made out the other side of Barnard's E after 9 minutes or so of integration. A pickle fork, as Harrington said. All right, now let's put everything back like it was and put it back in the order of best altitude. This is using Deep Sky Planner 8 over here. That's pretty cool, huh? Yeah, Ray says SharpCap only has really common objects. You're right. Rush E, Impossible Piano Music, best heard while watching this dark nebula. How about that? What the heck is a pickle fork, Papa Tech says. Don says, it's how you stick your pickle. Papa Tech, what's it doing in space? And that would be a large pickle. You're right, Papa Tech. How long till the launch, Papa Tech? We probably can't go watch it because it's probably copyrighted. Right? Would the launch be copyrighted? And what is it? What is launching? Oh, there it is. Live from the Cape, SpaceX Falcon launch. That's SFN, Space Flight Now. See, that might be copyrighted. How many minutes left? 3 minutes? So let's say SpaceX Falcon 9 launch live. Can we find something that's not copyrighted? How would we know? NASA should be not copyrighted, right? Oh wait, maybe this is not the official NASA channel. Maybe it is. NASA should not be copyrighted because it's a government program, right? And government productions aren't copyrighted. Tell you what, we're going to go and look at 25 seconds of this. I'm going to get my stopwatch ready. NSF is not NASA, Stu says. Bummer. Now here's SpaceX. Would that be copyrighted? Probably, right? Okay, I'm just going to play 30 seconds of this when you guys say it's ready to launch. Papa Tech says 2 minutes. So I'm going to get my stopwatch ready. What would be the best channel here? Which channel are you watching? Oh wait, Papa Tech, you're watching it live. Don says, wait for 1 minute and 10 seconds. You guys are funny. See, that's 16,000, 8,000, 501, 208. This one has 207,000. Space Flight Now. 137,000. They have 2 different streams going. 3 different streams. 35 seconds. So go. 12 seconds. $22, $24, $25, $26, $27, $28. I had to stop it. Well, bummer. T-minus 58 seconds left to go. Well, let's close this one and launch the other one. Let's watch this one. No, it says T-minus a minute. It's delayed. Oh, Pier-Tech's seeing it live. We're not going to be able to see it because it's T-minus a minute on that delayed. Bummer, right? T-minus 58 seconds still on this one. Can I jump forward?
Here at NASA's Kennedy Space Center. Joined tonight by Stephen Young. Through
Dragon, we had good intercom checks.
I see. Bummer, we got to stop it.
From the International Space Station.
Well, anyway, at least you got to see it on the pad, right? Okay, back to our letter E. Barnard's E. Let's take a picture of what's not there. Wait, let's tune this up a little better. A color match. And add some more mids. I think it's showing a little better now, isn't it? Something like that. Well, that's fun. Back to the pickle fork. It looked great, Pier-Tech says. All right. Now let's go look at Campbell's hydrogen star. And it's basically HD 184 738. Campbell's soup. No. Campbell's hydrogen star. Anybody know why this is special? I forget. Seems like we looked at this one. Oh, it's actually a planetary nebula, isn't it? I don't see it. It's object 59. Campbell's hydrogen star. This surprisingly bright planetary nebula, Campbell's hydrogen star, few people have seen it. The Herschels missed it. It's not an NGC catalog object. American astronomer William Wallace Campbell. Yes, I think we looked at this. The town next to San Jose is named after Campbell. Well, that's pretty cool, Tiffany. We saw Campbell's H star a couple of viewings ago, Stu says. Yeah, how did we not? How do we not mark an observation of that? But we don't have one. Wonder why. Why didn't we make an observation of it? We had actually observed this object once before. I'm so glad you think so, Ray. Ray's saying the ScopeCam view is awesome. Campbell stars are good food, Don says. You know, I'm wondering if it'll still look that good, Ray, though, when there's no moonlight. I think the reason why it looks as good is the moon is so bright tonight. I'm looking forward to seeing it when it's pitch black. We might have to run those little red LEDs on pitch black nights. Okay, take a look at the screen. This is an incredible star field. Oh, right there it is in the middle. I do remember it now. Because it looks so hydrogen alpha-ish. It definitely... I should go down here in this text. I keep forgetting to change this, guys. Too many things to worry about. Down here, Campbell's soup, Campbell's hydrogen star. Anyway, it definitely has the tint of H2. But otherwise, it looks like any other bright star. Let's zoom in on it. Did we do this the other night? I think we did. And let's pull our mids back. See if we can find that central star. You know what we can see? It changes to white in the middle, doesn't it? See how the middle is whiter and the outside is more orange. This is at 514% digital zoom. Oh yeah. See how that middle is just overcooked white. And then the outside has that orange glow. Now we're back at 100%. So let's add our mids back. And when we zoomed in with the mids down, we could clearly see with just 4 minutes of integration that the center was white and the outside. JM, thank you so very much for that gift. You know, that gift, that $5 gift, we'll invest that in Morocco earthquake survivors, and they're homeless. There are so many people that are homeless. Thank you very much, JM, for blessing the channel that way. Let's read what Stu says. It's a Wolf Riot star. You think? Massive stars that have completely lost their outer hydrogen and are fusing helium and heavier elements in the core. I guess so. Boosters incoming, Papa Tech says. Stu says, Wolf Riot stars are highly luminous objects due to their high temperatures, thousands of times the bolometric luminosity of the sun. 17th time the booster has landed. Always looks fake. Yep, it does. Tiffany, that's awesome that you thought it looked pretty. Well done, JM. Thanks so much for pitching in. Means a lot, brother. The outside looked orange. Well, that's weird. Campbell's hydrogen star didn't go off the list. So this must have been what happened the other night. It's not marked as observed. I can't even check it manually. So strange. This is a glitch in Deep Sky Planner. It doesn't check off, in other words. So it will always be there unless I get Phyllis to help us fix it. Bummer. I'm going to go down to Evernote real quick and make myself a task to write Phyllis about Campbell's hydrogen star won't check as observed in Cosmic Challenge. I'm going to do that tomorrow. Okay. Okay. Well, it's 8 till, so I guess we'll go ahead and still follow our cutoff time, even though I made us late getting started. Our next object is IC4997. I hope we haven't been there before. IC4997. Sky doesn't look quite as bad as it did before, either because we're in a different part of the sky or no, look, we're right in the same part of the sky, but I think we were seeing those clouds over toward the west more, weren't we? In this part of the sky, it's not as cloudy. But there were more here a while ago. Remember when we were trying to see Altair? And now we can see Altair more clearly. Look. Right? Like that's Altair. This is main spine of Aquila. And this is whatever that star was here. Ocab. Mm-hmm. Isn't that right? Or not? Now I've lost it again. This is Altair. Yeah, this is Altair, and that's Ocab. And this one was called Almizan III. Well, I think we learned a constellation tonight, or at least I did. Okay. Anyway, look where we're viewing. The RASA is right here. So it's just almost due southwest. We have a little community over here. It's called Mount Washington, and it does make a little miniature light dome right here. But we're up to about, 40 degrees in the sky. So I don't think it would make a light dome there. So that's part of what this light dome is. It's the moon here plus that community. Okay, back to our live shot. Let's reset our display histogram. Reset the big histogram. Back off our mids. Blacken our black level. And this is supposed to be IC4997, another planetary. Huh. Oh, that's not aligned properly, is it? It's because it doesn't align properly when we have to plate solve. It throws it off a little bit. Let's see what he says about this object. This is object 103 in his list of cosmic challenges. 103. And it's NGC 4997. Like our last challenge, Planetary Nebula IC 4997 lies within the borders of Sagittarius and is surprisingly bright, but extremely small. That combination makes this a great object for everyone, whether you're observing under the veil of light pollution or from a dark, rural location. Its intensity should shine through all but the most extreme situations. Studies show that this little planetary varies in brightness. Long-term studies conducted by E.B. Gostyavkova at Moscow University reveal that IC 4997 dimmed by as much as half a magnitude between the years 68 and 1985, only to slowly brighten again in the ensuing years. It's going to require active participation. He tells how to find it. Okay, let's use deep sky image annotation. Deep sky image annotation. So it's supposed to be right here. Right here. Wow, how would we have ever found that? Guess we would have had to use his directions. So memorize where that is. It's right here. Oh yeah, you can see a difference in the core again. Let's back up our mids again like we did a while ago. Oh, it's got a green color too, doesn't it? This is just 4 minutes of integration. And look, the center looks different on this. It's kind of darker in the center. Boy, I don't know if we would have ever noticed that, gang. Would we have? I don't think we would have noticed that. Had a green tinge to it. Must be oxygen. Oh yeah, he says that if you use an oxygen-3 nebula filter and blink back and forth, it's the only way to confirm which is IC4997, because he says it remains perfectly stellar even at 300 power, but with that filter in place, it appears brighter. And then when you take the filter away, the other stars outshine it. Very subtle bluish tint. You just found what William Herschel never saw. Not only did he not see it, it probably didn't even exist in his lifetime. Wow, that's cool. Herschel didn't see it. It might not have existed. Harrington. It's pretty cool. It's IC4997. And tonight you've seen it right here on Emerald Hill Skies. And I Hate Calvin Lim is asking Stu, does this mean that it's a Wolf-Rayet star? Stu says, no, the last one was. This is a planetary nebula. I missed the name. It was IC4997. IC4997. You're saying the last one, which was Campbell's star, or whatever. Campbell's hydrogen star was Wolf-Rayet. Good clarification, Stu. Hey, so we do this kind of astronomy. We try to do this kind of astronomy one night a week. We pick the clearest night we can find. On average, God willing, one night a week. If it's extra cloudy and there are no clear nights, or if there's wildfire in Canada and we don't have any sky, then sometimes we'll go for weeks at a time without being able to observe. We use this technique every time, so you can observe with us. So it's literally electronically assisted team astronomy. Electronically assisted team astronomy, ETA. And we do it every time here on Emerald Hill Skies. We always try to tune things up. Like this time I'll work on why did our audio mic malfunction. We'll try to avoid that next time. Because in the spirit of what could possibly go wrong, this is like a 7-ring circus. We've got a lot of things going on. And you guys are great to take part in the way that you have. Thanks so much for being with us. Ricky, we do a notification as a campaign, is that what it's called, on YouTube. So it's called a campaign? A community. We do a community announcement in YouTube, And we also do an email sent out from the list that you can sign up for at emeraldhillskies.com. If you go to emeraldhillskies.com, there's a YouTube form you can, not a YouTube form, there's a form there you can fill out. Or maybe, I think it gives you an email address to write to. And you email that email address and it automatically subscribes you to the list we use. If you like this kind of content, it would help if you subscribe, because then you'll get those notifications. And you could always click the bell and that'll give you a better notification. If you, as they say, smash that bell. You could also give it a thumbs up and that'll let YouTube know that you like this, so maybe it'll tell you about it next time. We love having you along because this becomes a lot more fun when we can do it as a team. And honestly, it means a lot that you guys are willing to take part, because without you guys being here, I think it would be like kind of lonely or something, you know? And since you guys are here, it actually becomes kind of like a party. So thank you for taking part. And tonight was especially fun because we were working on this list of challenges that are extra hard to find, not like the Messier Marathon or something. So thanks for the way you pitch in. Tiffany, it's kind of you to encourage. Ray says it's only clear when the moon is bright. Well, that's not always true, because I remember some nights it's inky black. But either way, Tiffany, thanks for being here. Joy, thanks for watching. That's Tiffany's dog. All the rest, Stu and everybody. By the way, Stu said IC4997 is a very young and very dense, very high nebular temperature of around 20,000 Kelvin. Whew. That is hot. We love you guys. Thanks for the way you are willing to pitch in and make this fun. We're going to sign off for tonight, but we'll be back as soon as we can. JM, thank you, and thanks for the way you pitched in for the world. Thanks to God for making all these cool objects that we can enjoy, and I hope you'll stop back at another adventure of Cosmic Challenge on Emerald Hill Skies. We'll see you next time. God bless and good night.